Hey everybody, welcome back to Old School Math. Today I'm going to show you how to do matrix multiplication by hand. Let's get started. By the end of this video, you'll be able to do the following two things. First, identify whether or not matrices can actually be multiplied. And second, you'll be able to multiply matrices. A couple notes before we begin. Remember, matrix dimensions are always written as rows by columns. To multiply matrices, you multiply all the elements in the rows of the first matrix by the elements in the columns of the second matrix. These are added together and they go in the corresponding element in your resulting matrix. Because of this, you can only multiply matrices if the number of columns in the first matrix matches the number of rows in the second matrix. This can be tricky to do by hand, and you're going to see that in just a minute, but it is possible. We're going to work through a few examples together. If you'd like to pause this video at any time and take things a little bit slower to see step by step what's happening and to take your own notes, that'd be a great way to watch this next portion. So let's take a look at example 1. We see example 1, we have a 2-row and 2-column matrix. And in matrix 2, we've got 2 rows and 2 columns as well. So the question is, can we actually multiply these matrices? We said the number of the number of columns in the second matrix has to match the number of rows. To figure out if we can actually multiply these two matrices, we want to look at the number of columns in the second matrix and the number. To figure out if we can actually multiply these matrices, we take a look at the number of columns in the first matrix and the number of rows in the second matrix. If those two numbers match, which they do, then we're good to go in multiplying our matrices. So we said we're going to take the row in the first column, or the row in the first matrix, and multiply it by the column in the second matrix. So let's do that together. We'll go ahead and make our new matrix bracket. We're going to start off by doing the first element in the first row by the first element in the first column. So we're going to do 2 times 5. And to that, again, we're going to add these together. 7 times 0, the second element times the second element. Then we're going to do the second row by the first column. So we're going to have negative 4 times 5. We're going to have plus 1 times 0. So we did our first row by our first column. And then we did our second row by our first column. Now this is where this gets kind of tricky. We're going to repeat this process with the first 2 rows and the second column. And that's going to go in the second column in our resulting matrix. So we're going to do 2 times negative 4 plus 7 times negative 1. Then we're going to do negative 4 times negative 4 plus 1 times negative 1. Now at this point we've got our matrix all set up. We just have to multiply and add. Be careful with your signs. 2 times 5 is 10 plus 7 times 0 is 0. 10 plus 0 just gives us 10. Negative 4 times 5 is negative 20, plus 0 is negative 20. 2 times negative 4 is negative 8, plus a negative 7 gives us negative 15. Last but not least, negative 4 times negative 4 is positive 16, plus 1 times negative 1 is negative 1. So we get 16 minus 1 is 15. So our resulting matrix is a 2 by 2. And something interesting happens here. When we write rows by columns, our resulting matrix should have the outer dimensions. The inner dimensions tell us can we multiply them. The outer dimensions tells us our resulting matrix dimensions. Let's take a look at this second 2, example 2. We've got a 2 by 3 matrix, 2 rows and 1, 2, 3 columns. We've got another 2 by 3 matrix. Before we start multiplying, let's see, can we actually multiply these? Do the numbers in the middle match? They don't match, so we can't multiply. I always have students asking, but what if we did this and what if we did that? Nope, the way the matrices are written, we can't multiply those. We're done. On this last matrix, we're going to take a 3-row by 2-column matrix. We're going to multiply it by a 2-row by 2-column matrix. Now these matrices don't have the same dimensions, but that doesn't necessarily mean that we can't multiply them. The columns in the first matrix do match the rows in the second matrix, so we can multiply them. We're good to go. The resulting matrix is going to be given by the outer dimensions here. So we know we're going to have a 3 by 2 matrix. Let's go ahead and draw our brackets. And let's multiply. We're going to take the first row by the first column. So 2 times 5 plus 6 times 0. We're going to take negative 1 times 5 plus 4 times 0. We do 6 times 5 plus negative 7 times 0. Be careful with your signs right here. Make sure you don't lose a sign somewhere in there. For our second column in our resulting matrix, we're going to do the first row by the second column. So we're going to have 2 times 5. 2 times negative 4 plus 6 times negative 1. We're going to have negative 1 times negative 4 plus 4 times negative 1. We're going to have 6 times negative 4 plus negative 7 times negative 1. And I'm going to write the resulting matrix below here because I'm running out of space. So let's go ahead and do our addition, subtraction, multiplication, all that fun stuff. 2 times 5 is 10, plus 0 is just 10. Negative 1 times 5 is negative 5, plus 0 is just negative 5. And 6 times 5 is 30, plus 0 is still just 30. In this second column, this gets a little bit trickier because we're not multiplying that second term by 0. 2 times negative 4 is negative 8. 6 times negative 1 is negative 6. 8 minus 6 is negative 14. Negative 8 minus 6 is negative 14. Negative 1 times negative 4 is positive 4. 4 times negative 1 is negative 4. 4 minus 4 is 0. Then 6 times negative 4 is negative 24. Negative 7 times negative 1 is positive 7. And negative 24 plus 7 should give us negative 17. And we have multiplied these two matrices. Now I know what you're thinking. There has to be an easier way to multiply matrices. And there really is. If you hop on a graphing calculator, you can do all kinds of operations with matrices in an instant if you enter the matrices into the calculator. I'm going to show you how to do that in the next video. Guys, thanks for hanging around. Thanks for watching this. If you like what you've seen, please subscribe.